Hello students, today we'll be doing a problem based on rectilinear motion. A particle has an initial velocity of 9 meter per second due east and a constant acceleration of 2 meter per second square due west. The distance covered by the particle in the fifth second of its motion is. So we have to find out the distance which is covered in fifth second. So as the constant acceleration is 2 meter per second square due west, this side, left side. So A is equals to minus 2 times of I. Why I? Because it is along x-axis. Similarly, initial velocity of 9 meter per second due east. 9 meter per second means on the right side along x-axis. So 9I. There is a formula for the nth second, as it is your fifth second. If it might be 4th second, 3rd second, 10th second, 12th second, and so on, we'll always use this formula. Sn equals to u plus a by 2 bracket 2n minus 1, where Sn is the displacement in nth second, initial velocity, acceleration, again nth second. At the place of u, it is 9i. At the place of a, it is minus 2i. At the place of n, it will be fifth second, 5. So if we'll substitute that, we'll be getting S phi is equals to 0. If we'll substitute that all the values, we'll be getting 0. What does this mean? That the particle displacement in fifth second you are getting equals to 0. Means what? It has started from its initial point and then once again came back to its initial point. That's why the value is 0. Now, in fifth second, the particle reaches at its initial position. So how it can be defined? Or it at 0 second it was here, and again at fifth second it is coming at again same point. Now in between this whole path, there is some point where the velocity is becoming 0. What is the time taken to reach till there? So if v is equals to 0, what is the time? So v is equals to 0, u is 9, as it is already mentioned, 9 meter per second. A is minus 2, as it is mentioned here. So if I substitute that, I am getting t is equals to 4.5. So to become v is equals to 0, the time is 4.5 second it has taken. 4.5 second, be very clear, 4.5 second. Here it is fifth second. So 4.5 to 5 second means only 0.5 second is remaining. Okay, so now what is happening? See, then distance covered in 0.5 second is how much? Let's take an example that this is the point where the velocity is 0, and from here till here the time taken is 4.5 seconds. So from here till here it is 0.5 second, because the remaining will be 0.5. So from here till here, if I'll take a motion, then this will become an initial velocity, and initial velocity is 0 we are considering. So distance covered in 0.5 second, u is equals to 0, s is equals to ut plus half a t square. Ut is your 0 because u is 0, half a is minus 2, and the t is 0.5. So s is equals to 0.25. Means what? From here till here the distance is how much? 0.25 meter. Is it clear this much? Now the twist in the problem, just have a look. It's fifth second. It's not in 5 seconds. It's fifth second. So if fifth second we are talking about, it's 4.5 and the remaining is 0.5. Means in 0.5, if it is covering 0.25 distance, then in previous 0.5 it would have covered double to this. Don't you understand? If I'm talking about a 0.5 second, I have to make this 1, 0.5 plus 0.5. If I'll make 0.5 plus 0.5, 0.5, which is, I got it 0.25 here, and from here I will be taking once again 0.5. Means from here if I'll take 0.5 more seconds, so it is coming double to this. I hope you understood. So total distance covered in fifth second will be what? It will be twice of this value. and this will give you 0.5 meter. Is it clear? Now once again I am repeating, at 0.5 second, the last 0.5 second, you got s is equals to 0.25. So for making the fifth second, every second will have one value, right? If I'm talking about, let's take 0 to 1 second, 1 to 2 second, 2 to 3, 3 to 4, and 4 to 5. If I'm talking about 4 to 5, so here 0.5 I have used it, I got this. So if I'll use the next 0.5, then I'll be using and getting double of this, and that's what I'm talking about here. I hope you understood this. With this, I'll complete the problem. Thank you so much.